So we've already talked about how to find angle measure when we have an angle that lies at the center of the circle. For example, that was our central angle theorem. Remember, the angle measure is equal to the arc measure. Those were the same. We've talked about inscribed angles, where the angle measure is half of the arc measure. Now we want to talk about two more theorems. What if we have angles that lie inside the circle? So they're not at the center, but they're not on the circle. Instead, they're here. They're crisscrossed. Like this. We've got two chords that are crisscrossing. Remember, these are vertical angles, so those have to be equal to each other. Those two angles that you see, those, and then these other two also have to be equal to each other because those are vertical angles. So you have two sets of congruent angles there. But the important thing is that the angle measure of any one of those is half of the sum of the arc measures. So for example, this arc, or this angle, excuse me, RTP, that is equal, that angle there, measure, is equal to half of the sum of the arc measures. Half of whatever RP plus SQ is. You're basically taking the average of those two arc measures to find the measure of those angles that open up to them. Then if you have an angle that is outside a circle, this little kind of ice cream cone looking situation over here, where the angle is outside the circle, instead of adding up the two arc measures that it intercepts, you subtract them. So you take the larger arc minus that smaller arc, and that will give you the angle measure that is outside the circle, and you divide it by 2, So take larger minus smaller and then divide by 2, and you would get that angle that is outside. Let's try some practice on this. Here's one. This says the measure of angle FB, or excuse me, arc FB is 42 degrees. So arc FB is 42. Arc AD is 58. What is the measure of angle AED, and therefore also the measure of FEB, because those would be vertical angles. So since these angles lie inside the circle, but notice they're not on the center, here's your center right here, we have to use that theorem that says we take 1/2 of the sum of the arc measures that they open up to. So half of 58 plus 42. Well, 58 plus 42 is 100. So we have to take half of 100. And that tells us that those angles each are equal to 50 degrees. You just take basically the average of those two arcs that it opens up to. Now here's an example of the little ice cream cone situation where we have to take half of the difference of the arcs that are intercepted. So we want to know the measure of arc GE. We don't know that. Call that X. If we know that HPF, angle HPF, is equal to 30, and then we know that arc HF is 20. So this is a little different because we're actually given the angle measure, and we need to find one of the arcs. Remember, the rule for this one was that the measure of angle, in this case HPF, so that 30, was equal to half of the difference, bigger minus smaller, of those arcs that it opens up to. So in this case, that would be bigger was X, GE, minus 20, the smaller one. So if we want to solve for X, we can multiply both sides by 2. We get 60. That will get rid of our 1/2 here. 60 is equal to X minus 20. Add 20 and we get 80 equals X.